Happy Thursday, everybody! Today we're going to learn about the distance formula. And yesterday we learned how to find the distance between 2 points on the coordinate plane using the Pythagorean theorem and right triangles. And today we're going to learn how to find the distance between 2 points on the coordinate plane using the distance formula. And this distance formula is one of those things that is foundational in math and will be with you for the rest of your math career, and is something that's going to be built on a lot in future concepts. All right, so let's get started today with how do we find the distance between 2 points using the distance formula. So let's begin with labeling my ordered pairs here. Let's look at number 2. So I have 1 point that is at 0, 3, and I have another point that is at -3, -2. All right. So what I'm going to do then is I'm going to use the distance formula. So what I want you to do is to write this down somewhere that you are certain not to lose it. The distance formula is going to be d equals the square root, and d stands for distance. And we're going to have x sub 2 or x2 minus x1 squared plus y2 minus y1, and all of that's going to be squared. Okay? So this formula is a combination of two formulas. It's a combination of your Pythagorean theorem of a squared plus b squared equals c squared. And it's also a combination of the slope formula as well. And if we had more time, I would show you how it was derived, but I'll leave that for your Math 2 teacher to do next year. So here's my 2 points. I have 0, 3, and 3, -3, -2. All right, so we'll let these points be x1 and y1, and we'll label these points here x2 and y2. And we'll just start substituting them into the distance formula. So my x2 is going to be -3. My x1 is 0. My y2 is going to be -2. And my y1 is going to be 3. And all of that's going to be squared. So then -3 minus 0 becomes -3 squared. And then -2 minus 3 is going to be -5 squared. So -3 squared is -3 times -3, which gives me a +9. -5 squared is -5 times -5, which gives me a +25. So now I add those two together, and I have d equals the square root of 34. And then I just need to find the square root of 34. And I'm going to round it to the 10th. So d equals 5.8. So that means the distance between these 2 points is 5.8. And that's how we use the distance formula to find this diagonal distance between those 2 points. Okay, let's look at the next one. So for the next one, to find this diagonal distance here, my point up here is 5, 1. And my point down here is -4, -2. All right, so same thing. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. And my points were 5, 1, and -4, -2. So we'll go ahead and make this one x1, y1, x2, and y2. And let's just start substituting things in. So x sub 2 is going to be -4 minus 5 squared plus -2. And then this is going to be -1 squared. So -4 minus 5 gives me a -9. And then -2 minus 1 gives me a -3. So -9 times -9 is a positive 81. And then -3 times -3 is a positive 9. So 81 plus 9 is 90. So the distance between these 2 points is the square root of 90, which rounded to the 10th position is going to be 9.5. So that means this horizontal or this diagonal distance right here is 9.5. All right, let's look at number 6. All right, so number 6 says to find the distance between 6, 8 and 5, -2. So we're looking for the distance between 6, 8. That's an ugly 8. And then 5, -2. All right, so let's go ahead and assign this as x1, y1, x2, y2. So x2 is going to be 5 minus 6 squared plus -2 minus 8 squared. So 5 minus 6 is a -1 squared plus a -10 squared. So -1 times -1 is going to be 1. -10 times -10 gives me a positive 100. So now the distance between these 2 points is the square root of 101, which the square root of 101 rounded to the 10th position is just 10.0 or 10. All right, so that's it for today. There's a person puzzle on Jacques Cousteau that you can do to practice your distance formula. And if you have any questions or need some more help, come and see me on Google Meet. Have a great day, everybody. Take care. Goodbye.